This video is one in a series that talks about the mathematics of vectors. Specifically, this video will talk about what happens when you multiply a vector quantity by a scalar quantity. It turns out when you multiply a vector quantity by a scalar, the result is also a vector. An example of this would be Newton's second law, where the net force is equal to mass times acceleration. Mass is a scalar quantity, acceleration is a vector quantity, so if you multiply m and a, you get the net force, and force is also a vector quantity. To show how this works mathematically, let's take some generic vector a and some generic scalar c, and we will find out what happens when you multiply c times a to get a new vector, b. But now we're going to have to find both the magnitude and direction of b because it is a vector quantity. To determine the magnitude of b, we're just going to multiply the magnitude of the vector a times the absolute value of the scalar c. That way we get a positive number for magnitude. Mathematically, we write it like this: absolute value of c times the notation for the magnitude of a. Now we need to figure out the direction of vector b. Now this is a little more complicated because it depends on whether c is a positive number or a negative number. If c is a positive number, that is, it's greater than 0, then it turns out that the direction of vector b will just be the exact same direction as vector a. They'll be parallel to each other. However, if c is a negative number, then it turns out that the direction of b will be in the opposite direction as vector a. They'll be at 180 degrees or anti-parallel to each other. So multiplying a vector by a negative number reverses its direction. To see how this works, let's try an example. Let's take some vector a, which I'll say is 5 meters per second squared. It's an acceleration vector, and we'll have it directed to the right. And let's let c be a scalar quantity. Let's say c is equal to 2. So let's multiply c times the vector a to get a new vector b. So to find the magnitude of b, we just have to multiply the absolute value of c, which is 2, by the magnitude of a, which is 5 meters per second squared. This gives us a new magnitude of 10 meters per second squared. And now the direction, because c is greater than 0, it's a positive number, it's positive 2, it turns out then that the vector b will be in the same direction or parallel to the vector a. So the overall result is that vector b has a magnitude of 10 meters per second squared and has the same direction as the original vector a. And I'll draw it out here as an arrow. So when I draw it out, you'll see that the arrow is twice the length of vector a, but it points in the exact same direction. Let's try a slightly different example. This time I'll still use the same vector a, but I'll change c to be a negative scalar, negative 0.5. And now when we multiply c times vector a, we'll get a different vector. I'll call it vector d. To find the magnitude, I take the absolute value of c, which is 0.5, and I multiply it by the magnitude of a, which is 5 meters per second squared. So the magnitude of d turns out to be 2.5 meters per second squared. In this example, I treated c as a unitless constant, so the units of d are the same as the units of a. Now for the direction, because c is now a negative number, that means it's going to reverse the direction of a. So instead of pointing to the right, like vector a does, vector d will point to the left in the complete opposite direction as vector a. So I'll draw the vector here pointing in the opposite direction and about half the length of vector a. And I'll just make it more explicit here and write that down, that you can see that the vector d is half the length of vector a and points in the complete opposite direction, in this case to the left. Multiplying a vector by a scalar quantity is actually a pretty simple process. In the next video, we'll see how we can start to add and subtract vector quantities. Thanks for watching, and have a great day.